Hello, developers. I'm Scott Hurry, pronouns he, him, and I'm excited to talk to you about retrieval augmented generation with AI, and specifically how Box can support your custom applications in that context. Joining me today is Alex Novotny, who will show you some demos to highlight the things that we're talking about, and a bit later we'll chat with the co-founder and CEO Jerry Liu from our partner LlamaIndex. We'll discuss RAG in the real world and how LlamaIndex can help you build complex workflows with your content and AI. Before we get started, though, let's take a second to define what we mean by retrieval augmented generation. More commonly known as RAG, this is a technique used with generative AI to augment large language model queries with the data specifically related to your AI query. It combines the power of the LLM with your data, allowing you to get the best answer to your AI query based on the information that you have. Imagine asking ChatGPT a question about a contract. As great as ChatGPT is, it doesn't know anything about that contract. For that, you need RAG. But AI can get pretty complex. You can have multiple agents all managing their own set of tools and contexts working together to achieve really amazing things. For today, we're going to break down RAG to its simplest terms. When we talk about RAG, there are really two main components, a retriever and a generator. The retriever is responsible for retrieving relevant information from a large knowledge base or document collection, while the generator generates coherent and contextually appropriate responses based on the retrieved information. More specifically, the retriever component can be used to gather relevant data from a variety of sources. Most often, this is in the form of a vector store. You can think of this as a specialized database that stores mathematical representations of small pieces of data called embeddings. In many scenarios, these embeddings have been retrieved in advance from multiple data sources and processed to be made available when you need it. You can also retrieve this data real-time. These embeddings capture semantic similarities between words and sentences, allowing for efficient retrieval of relevant documents. Once the retriever identifies potential candidate documents, it passes them to a generator component. The generator employs powerful language models like GPT-4 or Anthropic to generate responses based on the retrieved information. These language models are trained on vast amounts of text data and can produce human-like text by predicting what comes next in a given sentence. To illustrate this, let's think through an example of what a RAG application might look like. On the right is our user. We'll call her Tabitha. Tabitha is an account manager that wants to get a 360-degree view of the last year for her biggest client. Data resides in many places. Of course, there's files in Box. We have account records in Salesforce. Maybe you've got company data from Crunchbase that you've already indexed into your vector store, and of course, public data on the internet. Tabitha doesn't want to go to all these places and get the data herself. She just wants her report. With RAG, we can retrieve the relevant data from all of these places and use it to supplement the query in the LLM. AI agents are smart enough to evaluate your prompt and determine which data sources it needs based on the tools it has access to. It can then pull that data, ask the LLM all by itself. So Tabitha just goes to Slack, asks for her report, and the AI magic does the rest. So with that scenario in mind, let's talk a little bit more in depth about RAG and why we are excited about the possibilities. The key advantage of using RAG in AI-powered application lies in its ability to provide accurate and informative responses by leveraging pre-existing knowledge. By combining retrieval-based techniques with language generation capabilities, RAG can handle complex queries that would require a deeper understanding beyond simple keyword matching. This process offers several benefits. First, it enhances the user experience by providing more precise answers tailored to those specific queries. Secondly, it enables developers to leverage existing content efficiently without having to manually curate the content or data they think they might need for each prompt. This saves time and resources while maintaining accuracy. In addition, RAG allows for continuous learning as new content becomes available. By updating or expanding the underlying document collection regularly, RAG can adapt to changing context and provide up-to-date responses. We at Box are differentiated by our enterprise-grade security and our ability to scale and handle all of your content in a secure and permissions-integrated way. As Gen AI continues to gain ground across corporate environments, combining the power of AI with the security and reliability of Box enables you to build applications that help you, your employees, and your customers get the most value from your content. So now let's talk about ways you can use your secure content in Box with modern generative AI technology to power your RAG workflows. There are 3 techniques that we typically recommend to developers as you think through the implementation of AI with Box content in your corporate environment. Number 1, use Box AI. Let us handle the complexities of security, permissioning, RAG, and infrastructure. You can also use the Box platform, including the Box AI API, to retrieve your content or aggregate Box AI responses to your prompts or citations we identified to answer the prompt for you. You can also use Box APIs to index Box content yourself. Let's take a look at each of these in a bit more detail. Relying on Box AI API for retrieval augmented generation presents a significant opportunity for you to streamline your AI workflows. By leveraging our infrastructure, you can offload intricate tasks to Box and get your answer quickly with just a few lines of code. The beauty of this approach lies in its simplicity. A concise prompt initiates a cascade of actions orchestrated by Box AI, from indexing and splitting to embeddings, vectorization, and seamless communication with large language models. Every aspect is handled for you by Box. It's really an opportunity for you to realize the power of Gen AI without having to build, host, and maintain a complex architecture. We also handle access permissions for you, alleviating the burden of ensuring end users can access content they shouldn't. By entrusting these complex operations to Box's sophisticated infrastructure while capitalizing on its array of models, developers can elevate their output quality significantly with a lot less work. We also have spent a lot of time building API endpoints to handle the tasks you need. You can use the Box AI API to ask questions about a document, generate text, or even extract key value pairs from your document to help you get just the specific information you need from your unstructured data. And because of our platform-agnostic approach to trusted LLMs, we offer you the flexibility to choose the right tool for the right job. Of course, we choose models specifically for their ability to provide quality results for a given use case, but we also understand that you may prefer a different model. Your use case might work better with a different provider. So we provide you with a way to choose your own model by specifying the one you prefer from our curated list of models at the individual API call level. So even one application can use more than one model. This versatility empowers you to tailor outputs precisely according to specific requirements or experiment with diverse approaches. While using Box AI is a fantastic tool in your AI toolbox, you may require a broader set of data to provide context for your RAG workflow. Box Platform is our developer platform which provides endpoints to do most of the things you can do in the Box UI. In the context of RAG, you can do things like download files, retrieve various representations of files like text, PDF, or images. You can search for files or even use something like metadata query to filter the files that you need based on those specific key value pairs. You can do all of this with any of our SDKs, making this approach much more about your use case and much less about figuring out how to build and manage the low-level Box platform integration yourself. And of course, you can still use Box AI APIs. With this technique, you can use Box AI to generate summaries or extract relevant information from cited sources and convert them into vector embeddings or use them just in time. This can serve as a foundation for your AI application without having to process your Box content manually. With this, you can gain insights from your most secure content in Box without having to move your files outside of our world-class security controls. The app will only have access to the content specifically shared with either the application's service account or the specific user the application is acting on behalf of. This is a quite powerful way and a secure way to keep your content safe while getting the value out of it that you need. We also understand that you may not have access to Box AI, or you may want to have more control over the documents you use in your application. With this approach, you can pre-index your Box content in your own external vector store and retrieve the embeddings directly from there. If you choose to index your own files, our APIs and SDKs will provide you with the toolset that you need to do so seamlessly. We have also built loaders and retrievers in several popular AI orchestration frameworks like LangChain and LlamaIndex. Our recommended approach is first check for a text representation. This is the easiest and least resource-intensive way to get your content. Of course, files like images, videos, and scanned PDFs do not have text representations, so for these document types, you can get a PDF or an image, or you can simply use the download endpoint and save the file locally. By retrieving your files from Box and incorporating them into your vector store alongside other data sources, you can really enrich your AI application's knowledge base and enhance its performance when using models with RAG. Just remember, you must handle any privacy considerations related to accessing sensitive information stored in Box while adhering to your applicable data protection regulations within your organization. But enough talk. Let's see what these techniques actually look like in real life. For that, I'm going to hand you off to my colleague, Alex Novotny.
Thanks, Scott. Today we're going to walk through 3 demos using LlamaIndex, LangChain, and Pinecone. All of these are meant to help jumpstart bringing Box into your RAG applications. For our first demo, we're going to look at connecting Box and LlamaIndex. We'll demonstrate how to index content stored in Box into a ChromaDB vector database using Hugging Face LLM model embeddings. The process leverages LlamaIndex to seamlessly integrate these components, enabling powerful search and retrieval capabilities. With this setup, Box content becomes easily searchable, with advanced semantic understanding paving the way for more intelligent queries and automation. Let's check out the demo. For this demo, we'll be working with a sample dataset of 50 lease contracts. Each contract contains multiple start and end dates, property types, examples 2 or 3 bedrooms, tenant names, contact emails, rent amounts, and payment terms. Let's explore this one. HAB 207. This is a contract for a dual residential pod, currently leased by Rosalind Franklin. Since we are using Box, we can leverage Box AI to quickly summarize the document for us. But for this demo, our focus is to show how unstructured content stored in Box can be integrated into AI-powered applications. Let's start by running this Python script. First, we instantiate a Box client object that will allow the LlamaIndex box reader to connect to the Box API. Included in the Box Reader class, there are a few more tools to help your application interact with Box. In this case, we are using the search resources method to find the content we want to index. Next, we invoke the load method, which will load the content from Box into a LlamaIndex document object. We could have sent all of the Box document IDs into the load method, but in this case, we wanted to have some sort of visual feedback on the progress of the indexing process. We can see the script processing the documents one by one. Next, we initiated the Hugging Face embedding model and created a ChromaDB instance and storage context. From here, we create the index from the list of document objects. And once the process is complete, we can query the index. To test this, let's prompt it about the leases. I'm going to run another script within this repository. We have some pre-set up commands for this example. I'll ask it to do number 2, which is describing the HAB2 type properties. It lets us know that the HAB2 type properties are dual residential pods located in this particular plaza on the moon. Let's also see when Isaac Newton's lease ends. As we can see, it returns a lease end date of May 31st, 2027. In this demo, we've showed how to make content stored in Box available to your AI-powered application with LlamaIndex. If you want to take a deeper look at this example, scan the QR code and navigate to our GitHub repo. Next up, let's take a look at LangChain, another major framework solution that helps create content-centric solutions with AI. In this demonstration, we will employ real-time retrieval using the Box retriever from LangChain Box, relying on Box AI query results and citations. With this approach, you are able to let Box AI do RAG on your behalf to augment your LLM query, in this case, the LLM being OpenAI. Let's see this in action. This example will demonstrate using Box AI to provide a long description of a character from 5 feet high and rising, a script from Peter Soleil, and then use ChatGPT to recommend 5 actors to cast in the role based on that description. Here is the script in Box. If I go to the code example that we have, and I run the script, a LangChain agent is spun up to process the script for 5 feet high and rising, summarizing the character who Victor is. The agent then decides what to ask OpenAI. It then provides 5 actors who would be a good option for playing that character, as well as the reasons why. In this demo, we've showed how to make content stored in Box available to your AI-powered applications using LangChain. If you want to take a deeper look at this example, scan the QR code and navigate to the setup instructions. Last but not least, I'd like to show off Pinecone. If you aren't familiar, Pinecone is a scalable cloud-based vector database. What exactly does that mean? Let's dive in and find out. First, let's ask, what is a vector database? It is a way to store and retrieve embeddings so that you can find results that are similar in meaning rather than literally the same. Here, you'll see a simplified visual of what a vector database looks like. This representation is 3-dimensional, but in reality, vector databases are the same number of dimensions as the underlying embeddings being stored, which in our demo will be 1024. In this graph, I have placed dots that are similar to each other closer together. For example, on the left side are living things that aren't animals, the right side, inanimate objects, and the bottom side, animals. Apple is a fruit, but the words apple and fruit are fundamentally different. Apple could also be slang for a MacBook computer, and cricket on the bottom could actually refer to the cell phone company. So how are the embeddings stored in Pinecone created? Let's assume you have several text documents stored in Box or other content silos. The first step is to load or extract the text data from those individual documents. Afterwards, that text should be split into several chunks. This is called chunking. Chunking allows you to store more logically similar pieces of data closer together in the vector database. Think about a car manual. You probably aren't going to read the entire thing if you're looking for just the maintenance schedule. You're probably going to go to the index, find the page or pages that talk about maintenance, and flip to that section. Once the data is chunked, an embeddings model, which most LLMs provide, is used to generate strings of numbers like shown in this graphic. Those strings are then stored in the database nearest similar embeddings, alongside other relevant data like file name, date created, etc., ready to be queried at a later time. So how does this all come together to actually make a full AI-powered application? In the demo today, we are going to show something similar to the previous demonstrations that we've shown earlier today via a question and answering service. The question input by a user is transformed into embeddings using the same model as the original content. The vector database is queried, and similar results are returned, as shown in blue on the graphic. The question and result are then used to create a prompt, which is then sent to the LLM to generate an answer that is shown to a user. Now, let's see the demo. This demo will show off indexing and searching several pages of our Box developer site. For the sample dataset, I'm going to use these markdown files that make up the site. If we look at this one, you can see that it's talking about our file request API. To get started, let's create an index in the Pinecone console. I'm going to click Create Index. I'll give the index a name, like Pinecone Demo. For dimensions, I'm going to use 1024. And I'll use the rest of these options, I'll leave them as default. Like in the previous examples, there are 2 scripts that come with the demo, one for indexing the content and one for querying it. To index the content, let's run the main script. This demo grabs the text representation that Box automatically generates for all text-based files, chunks it, and stores it alongside other relevant metadata like file name, created by, etc. Once the script is finished processing the files, we can see the indexed content back in the Pinecone console. Now that the content has been indexed, we can query the database by running the query script. This script uses the new Pinecone Inference API. This allows you to grab relevant content for the query posted. It then sends the query and relevant content over to a LLM to answer the question, which in this case I'm using OpenAI. I'm going to ask it, how many endpoints does Box offer for using file requests? And then we can see it correctly identifies the various endpoints that we offer for file requests. In this demo, we've showed how to make content stored in Box available to your AI-powered application using Pinecone. If you want to take a deeper look at this example, scan the QR code and navigate to our GitHub repo. Now, let's head back to Scott for a Fireside chat.
Thanks, Alex. Those demos were pretty amazing, and I really appreciated the one, especially about LlamaIndex, because right now we're going to be talking to Jerry Liu, who is the co-founder and CEO of LlamaIndex, about some really cool stuff around RAG. So, Jerry, I really appreciate you taking some time to talk to us today. I would really love to just give you a chance to introduce yourself and LlamaIndex and some of the cool stuff that you're doing.
Sounds good. Thanks, Scott. Hey, everyone. I'm Jerry, co-founder and CEO of LlamaIndex. Our mission as a company is to enable all developers to build AI knowledge assistants over your enterprise data. And so happy to dive a little bit more into details. But basically, our goal is to make sure that there's plenty of use cases and technologies emerging as LLM foundation models are getting better. And we want to empower developers to build all the high-value use cases and agents that people are seeing these days with respect to their unstructured, semi-structured, and structured data.
Very cool. I will say I have had a chance to play around with LlamaIndex. Obviously, our team here at Box has built some connectors that we've been able to share with some of our customers and even some non-traditional Box developers, and it's been very cool. I would really love to get your take, though, on RAG in general and sort of what is the importance of RAG and what is sort of the role of the orchestration framework in that.
Totally. So I think maybe taking a step back, I think what people really want to do, right, and taking a step back from RAG specifically as a technique is to just figure out some way to load data into the context window of a language model and then orchestrate over that data, basically solve a task. I think probably the simplest task that people are solving or have solved, last year is basically figuring out how to do basic chat and search over your unstructured data. And so that's basically how RAG as a technique was born, because from your unstructured data, there was basically this technique that was relatively simple, but you could pretty easily, in about 5 to 10 minutes in a Jupyter notebook, use this technique to build like a little ChatGPT assistant over your data. And so the use case there is for a knowledge worker, they're able to input like some natural language input and get back some chatbot response. But there's other use cases, and especially as the world is moving more agentic, that people are excited about that leads to basically greater degrees of automation as well. And so, for instance, and we talk about this in some of our talks, but right now, if you use just basic off-the-shelf RAG techniques, and a lot of people realize this when they start off, it's okay at answering simple questions and giving you back simple results. But if you want to ask a complex research task, please write this entire paper for me, or actually go in and synthesize insights from 5 different data sources, it can't really do that. And so what we're excited about is actually adding this agentic automation layer in front of both the inputs and outputs of this overall data interface, combining different data interfaces together to help solve more sophisticated tasks for knowledge workers. Some example use cases include, for instance, artifact or report generation, being able to generate like an entire essay, a research report, a slide deck, an Excel sheet from some bank of information. And oftentimes, being able to generate this entire output requires a multi-step interaction as opposed to a single-shot interaction. And so when we think about RAG, it's really just a core technique that enables retrieval. And the initial use case is question answering. But really, the more general kind of like architecture to follow is you have a bunch of different data interfaces. You have unstructured, semi-structured, structured data. You have an agent that accesses this data for some task at hand.
Yeah, it's very cool. Some really cool things happening in the agentic space specifically, I think. But for us at Box, we typically focus on the enterprise space. And so as we think about what you just shared, I'm really curious what your take is on how that RAG is sort of shaping up in that space. What are you all seeing around enterprises and how they're using RAG specifically, but also some of the agentic approaches that are happening today?
Yeah, we're really excited about our partnership with Box because the data sources that users and folks typically put within Box are pretty much like precisely the data sources that we are the best at. And so I would say, we've spent a lot of time investing in how do you actually create this new type of data ETL stack that works really well over your unstructured documents. This includes everything from PDFs, PowerPoints, Word documents, HTML files, and more. And we basically do all the steps within RAG, but we focus on making sure that every step works really well and that's integrated into something that's, accurate over an end-to-end QA system. So, for instance, one thing that we work on is parsing, being able to parse really complex documents with a lot of like tables, charts, and images from like a research report, earnings deck, and more, and being able to really represent all the information from that document the right way. And we do this, for instance, better than kind of off-the-shelf open source parser, where it might mess up and hallucinate over the tables, the charts, the images, stuff that's a little bit more complex than text. And so some of the top use cases that we see, we work on a lot of the core technical components and make this entire end-to-end stack really good. And then this leads to basically like value unlock for the enterprise use case. And so, for instance, like some of the top use cases that we see include like a ChatGPT assistant for your investment banking team, your internal knowledge workers, whether you're a consultant, a banker, kind of like healthcare professional. We worked with different enterprises across these domains over these like common file types of unstructured data. And within these enterprises too, especially over this data, and like, I'm sure your team knows this better than I do, but there's a lot of companies with just vast troves of documents that are basically all in PDFs. They then want to move beyond kind of like the simple search and retrieval pattern that I mentioned into something that's slightly more agentic. And so, we're seeing that progression. I mentioned this too, as like the world goes from like simple chat QA to something that's more agentic as well. And we're seeing this within the enterprise too.
Kind of building on that, we were at Box, we were really privileged to sort of be a sponsor at the LlamaIndex Agentic Hackathon that took place a few weeks ago. And to your point, there were some really amazing things where people were just tying multiple agents together to solve these really complex problems. And, for us at Box, it was kind of a new thing for us to go into that space and to be sponsoring a hackathon of that nature where a lot of the participants were really sort of not your core enterprise developers, but more people who are kind of on the bleeding edge of AI. And I was really blown away by some of the projects that we saw come through that. I'm curious your take on sort of that event. And for me, it was a great proof point of our partnership. But I'd love to hear your thoughts on the event and also how you saw Box kind of fitting into that.
Yeah, I think the event for me, the high level lesson that I took away from that was that are it like the way that developers are building LLM applications these days aligns with our overall understanding of the state of the world. That people are moving a little bit higher up the abstraction level from kind of like really trying to figure out how to make RAG work to building like more complex orchestration systems on top. And so I took a look at some of these projects, which basically involve, as you said, like multi-agent solutions where you decompose this overall task into some set of agents, and agents are very much embedded in the control flow of the program. And so every agent, it might just be like a simple function, but it uses like LLMs and reflection and tool use and all these things to basically figure out a task. For instance, performing research, generating some output, deciding whether to kind of like pass information from one to the other. And so like it's actually quite interesting just looking at the developer patterns, because I remember we did a hackathon back in February of this year. And so a lot of people there were still figuring out like some of the core components that go into a RAG stack. And I think one thing that was really cool to see is that during this hackathon, and I think we've given a lot of resources to help them out on that piece, but like a lot of folks were actually just building just agent systems, and the RAG piece was almost taken for granted, which is great, because I think like over time, and this is the way that like kind of dev tooling works. Like everything moves higher up the value chain over time, and it's cool to see that by freeing up your time from solving some of the core RAG components, people have more time to actually build more complex agent systems that again like generate more end user value.
Yeah, totally agree. Like I said, I was blown away by some of the things that people did, and I think early on in sort of this generative AI explosion that happened a year ago, people were really thinking, okay, ChatGPT is awesome, like we can ask a question and it gives us answers, but I think people quickly realized that the answers are only as good as the information that the prompt is given, that the LLM is given. And that's been a really big opportunity for Box, because obviously we have all of an enterprise's unstructured data living within Box's walls. And then we also are able to handle sort of the complexities around security and compliance and permissioning. And so I think the difference that we've seen over the course of a year, where people are going from ChatGPT is cool, what do I do with it, to now building these complex systems and using all of their unstructured data that it is living in Box to sort of feed into those workflows has been really amazing. And so
Yep.
Definitely want to say thanks for including us in that event. It was a blast.
For sure. And actually, this is a bit of a tangent, but related to your point around the enterprise like access controls and security and all those things. These things are super important. And one thing that we've realized from both working with like the hackathon folks, but also enterprise developers, is that when you first prototype like a RAG system or more generally some sort of like knowledge system over your data, you don't really think about these things. So it tends to be very easy to actually build something in like 10 minutes. That's a demo. But then the moment you try to actually scale this into a production pipeline, it gets a lot more complex. And so that's actually one core thing that, why we built, Llama Cloud as part of our managed offerings, because we've realized a lot of enterprise developers actually want to build like permission-aware RAG that actually indexes not just like the core text, but the right level of metadata on these files. And they don't just want to load this data once, they want to build a persistent pipeline that like updates and refreshes, every few hours or kind of like on demand whenever like permissions change on the files. And when you kind of deploy your AI engineering resources to building this entire pipeline, things get a lot more expensive than like building a 10-minute demo. And so I think that's actually something that's quite interesting, because I think, like a lot of data sources or a lot of folks do use Box. There's a ton of documents within Box. And then people don't realize that actually trying to load all these documents and build something in production is actually quite challenging. And so that's something that we've been aiming to solve for a lot of these developers for a while.
Yeah, totally. And I will say, having used LlamaIndex and specifically the box reader to kind of demo what this looks like, there's so many complexities in the AI sort of workflow that LlamaIndex really takes care of for you. And I think when you combine that with the power of Box and letting us handle kind of permissioning and security, it really makes for a small amount of code to do really compelling things. So I think this partnership is really cool, and I'm looking forward to seeing what people do, combining the powers of our applications and framework to build really cool stuff. So I'm really curious, kind of what's next for LlamaIndex. Where are you headed? I know Llama Cloud is either almost out or is out now. Really excited that the Box connector is live with that. But also curious, where are you thinking this is going in the next, year or so? What are you all working on? What would you like to share with our audience that maybe they could get excited about?
Totally. And so at a high level, we're basically aiming to build the stack to enable developers to build these high value production grade knowledge assistants over their data. And I think so far we've built some of the core components in that stack, but there's still more to build. And so just to give the audience a sense of what we have right now, I've mentioned Llama Cloud, and Llama Cloud basically is our AI knowledge management platform for your agents. And so it'll connect to a data source like Box. It'll be able to crucially handle that ETL stack to basically transform your unstructured data into a format that is LLM ready for your AI agents to consume. And we've been working very deeply on that. And over time, we're going to add more data sources, for instance, semi-structured, maybe structured as well, more indexing retrieval capabilities on top of this, and also kind of the surrounding ecosystem to enable you to index larger sources of data and really centralize that behind a core interface. So that's the data foundation layer. Above that, there's like a compute layer where right now, we have this like core orchestration framework. And at the hackathon, a lot of people were using it to build with workflows. It's like our core abstraction that's event driven, customizable, flexible, and basically allows you to define an architecture for your agent system. And so far, what we're working on beyond that is really the steps to help you deploy your agent into production, and then be able to have all the capabilities to not just build this in a prototype manner, but actually host this through an API with like full auth and governance and all these things. And then basically having this like compute layer enabling you to actually orchestrate your agent workflows with the core UXs that people find valuable. So human in the loop, state management, and so on and so forth. So we're actually really bullish about tackling this like end-to-end data foundation to the compute layer and really integrating that end-to-end.
Yeah, very cool. Again, Llama Cloud, I was pretty excited about it. I actually did a demo internally here at Box a few weeks ago just to show how easy it was to use your Box data in conjunction with even just with the playground in Llama Cloud. So again, really excited about that and really looking forward to seeing what people are going to do with it and how they're going to combine the power of your framework and our content management to build really cool and compelling things.
That's awesome.
Yeah, thank you, Jerry. This has been a great conversation, and I really enjoyed learning from you and hearing what LlamaIndex is doing. And I just want to say thanks. I know you're a busy person in this quiet area that we call generative AI, and so appreciate you taking the time and sharing your insights with us and our audience.
Thanks, Scott, for having me. It was great to chat, and super excited for the Box and LlamaIndex partnership for the future.
I am too. And I want to say thank you to everybody who's watched this session. I really get amped up about talking about RAG and how you can get all this value out of your content using generative AI. Look forward to seeing you at BoxWorks at Pier 27. We are going to have a developer zone booth there, so hopefully you can stop by and talk. Also, LlamaIndex will be there in our AI pavilion, so plenty of opportunities to continue the conversation. Look forward to seeing you. Appreciate your time. Have a great day.